Hello everyone, I am Pushpita Chanda. I am a PhD student at IIT Delhi under University of Queensland and IIT Delhi joint PhD program. I am a PMR fellow, so I am one of the TA for the Newtonian Mechanics with example. I took a class on last Tuesday, but due to some technical glitch, I could not record the audio with it, so I am re-recording the class. I'm sorry for the inconvenience. Thank you. So I'm just mentioning what I recently explained in the class. So we're gonna discuss what is vector. In also the professor has explained in the class what is like vectors and scalars. What is vector addition, what is vector product. So first I want to discuss some quantities which quantities are vectors and which are scalar. The first I want to discuss what is weight. So basically what weight is, whether weight is scalar or vector, we want to discuss it. We know weight is mass into the gravity. So the gravity is basically a kind of acceleration. So acceleration has direction as well as a magnitude. So here we can say that weight is a scaled gravity, scaled because of the multiplication by the mass. So gravity is kind of acceleration, is kind of acceleration in the sense gravity is a acceleration towards the center of the earth, and also it has the same dimension as the acceleration. So we all know what is gravity. So basically weight is the mass into gravity. So weight is also a vector. The next is calorie. So calorie is a scalar quantity. Calorie we know is the how much heat it is associated with heat, latent heat. So we know calorie is a scalar, and the specific heat, it also doesn't have any direction, as well as calorie, it doesn't have any direction and also doesn't follow the vector addition. Basically one quantity, if it is a vector or not a vector, a scalar, how can we decide? We decide that if it has a direction and also it follow vector addition. Like you can say that electrical current is a vector because it has a direction, but still we cannot call it a vector because it doesn't follow the vector addition. So vector addition is equally important. Again, the next quantity is momentum. So we know what is momentum. Momentum is mass into velocity, and we know velocity has a direction and it follows vector addition. So momentum is also a vector quantity. The next thing is density. So we know density is basically mass per volume. So mass and volume both are scalar quantity. So density is also scalar quantity. Although these things, the density doesn't have any kind of direction and doesn't follow the vector addition. The energy um, energy doesn't follow the vector addition, does not follow the vector addition, and also it doesn't have the direction. So you know that calorie is kind of a unit of energy that create heat, so that is calorie. So basically calorie and energy both are scalar. So 1 calorie is the amount of heat required at a pressure of 1 standard atmosphere to raise the temperature of 1 gram of water 1 degree Celsius. So the heat here is the energy. So basically energy and the calorie both are scalar. Volume is mass by density. So it is a ratio of two scalars and doesn't follow the vector addition and doesn't have any direction. So basically volume cannot be a vector. Then the distance. So distance is the scalar. Always remember the distance between 2 points A and B in a ground or space. It doesn't have any direction. So distance between A and B and is equal to distance between B and A. So it also doesn't follow the vector addition. So we can say that distance is a scalar quantity, but displacement is not, because the displacement from A to B is defined by AB, but displacement from B to A, the displacement from B to A, and this is A to B, is have opposite direction. So AB is equal to minus BA. So the displacement have a direction and it does follow vector addition. So displacement is vector. Same way, speed is scalar and velocity is a vector. Speed doesn't have any direction and also doesn't follow vector addition, but velocity has a direction and also follow the vector addition, that 50 km/h in north. So we can say it 50. Why? Later we can see that this is north, this is south. So this is y negative, this is x in this direction. So now after that we will discuss some vector addition rules, that is a plus b is equal to b plus a. This is the commutative law of addition, and let us see how we can prove that. So here is a like we can take OP which is equal to A and OR which is equal to B. So we know we can shift a vector. It doesn't change. If it doesn't change its magnitude or the direction, the vector is same. So here PQ is the same length of OR and they are in the same direction. So if OR is vector B, same as PQ is also a vector B. Same for OP and RQ. If OP and RQ has the same direction, we can see, and the same magnitude. Here in the picture you might think that the length is not same, but they are actually same. For the sake of simplicity we say that. So OP is equal to RQ, which is a vector. Now we first want to compute A plus B. So we need to connect the tail of A to the head of the B. So here tail of the A, then head of the B. So we join OQ, that is A plus B. So OP plus PQ is OQ, which is A plus B. Now we want to join B plus A. B plus A means we have to join the tail of the B to the head of the A. So here OR is B, then RQ is A. So it is B plus A. So that is also OQ. So we get to see that A plus B is OQ and B plus A is also OQ. So we can say that the vector holds commutative law. So okay. Then the second law, that is associative law, that A plus B plus C and A, if we add B plus C, then add A is equal to B. If we add A plus B, then add C to the resultant. That is called associative law of addition. So here we can see, here we took a quadrilateral which have four sides. So here ORQP is a quadrilateral. Yeah, OPRQ, whatever you can say. Let's see. OPRQ is a quadrilateral. Okay. So OP we assume is A. OR is no. OP is A, PQ is B, and QR is equal to C. So first we join B plus C. So we need to add that from the tail of the B to the head of the C, which will be PR. Okay. So when we have the PR, then we need to join A plus B. So A plus B plus C will be A plus PR, which is OR. Okay, so this is A plus B plus C. So here, so when we add A plus PR, so we need to join from the tail of the A to head of the PR. So this is OR. Now we need to know what is A plus, what will happen if we add A plus B first, then C. So to add A plus B, we need to join from the tail of the A to the head of the B, which is OQ. Then after we get OQ, here we want to get A plus B plus C. A plus B is OQ. Then we need to add plus C with OQ, which will be OR. Because if we want to add OQ with C, then we need to join the tail of the OQ to the head of the C. In all this discussion, when I say tail of a vector, then I denote that from the vector from this side, and head is where the vector ends, or that side. So we can see at however we want to join, like add A plus B plus C, whatever summation we do first, whatever vector summation we do first, we get the same result. So vector hold the associative law. The order doesn't matter. Then there is commutative law of amplification, that MA, which is a scalar, is equal to AM. This is a multiplication. So we can multiply the magnitude of A, but it will not change the direction. So we can write this way or either way. Same way, M and A, we can multiply N with a vector and change the magnitude of the a, then again multiply with another scalar, or we can multiply two scalar and whatever we get as a product, that product can be multiplied with a, we will get the same result. So it doesn't matter if we multiply m and n, then we multiply the product with a, or we multiply m and n one by one with a. So that is called associative, okay, associative law of multiplication. So then after that we goes to the another law of vector, which is m plus n into a is equal to ma plus na. So it says we can add the scalar and then multiply with it a vector, and also if we can multiply the scalar one by one with a vector, then plus add these two vector, the like result will be the same. This is the called distributive law. Another distributive law is m into a plus b is equal to ma plus mb. So which means we can add the vector, then multiply with a scalar, and we can also multiply the scalar with each vector and add them. In two scenario, the effect will be the same. So we need to remember these 6 rules. Now I want to give you some examples regarding vector addition. So the first question is, an automobile travels 3 miles due north, then 5 miles northeast. Determine the resultant vector. So first we need to like in a graphically we need to present 3 miles north, then 5 miles northeast. So basically the direction northeast, northwest, southeast, southwest, they are at 45-degree angle. North is like 45-degree north of east. Basically northwest is 45-degree north of west. This is northeast. This is northwest. So we know that for northeast, x and y both are positive. Like this is the northeast direction. So it x projection is positive and same as the y projection. For northwest, the x projection is negative, but y is positive. The y projection is positive. For west south, you can see both the projection in the negative direction. For southwest and for southeast, we can see that x projection is positive direction, but y projection is in negative direction. So north is considered positive y direction, south is considered negative y direction, east is considered positive x direction, west is considered negative y direction. East is positive x, sorry, the west is positive, the east is positive x and the west is negative x. Positive x is east, positive y is north, for north south kind of calculation. So here we need to go 3 miles north, which is OA in y direction, and AB northeast direction in 5 miles. So we need to do this vector calculation with by adding the x projection and y projection, then obtain the magnitude and the direction of the resulting vector. So the y direction, 3 miles in y direction, so this is basically 3y. Okay, the AB has projection in x direction, is also in y direction. X direction projection is what? AB cos 45 degree, because it is making 45 degree angle with this axis, x axis. So 5 cos 45 degree x plus, here we need to calculate the y axis projection, which is 5 sin 45 degree. So AB, we can write AB as a 5 cos 45 degree x plus 5 sin 45 degree y. Now we need to add. So we need to find what is OB. So basically OB is OA plus AB. OA is 3y, AB we can write this. So cos 45 degrees 1 by root 2. We now need to add the coefficient of x unit vector and coefficient of y unit vector. So we'll get 5 by root 2 x plus 3 plus 5 by root 2 y. So the OB is 5 by root 2 x plus 3 plus 5 by root 2 y. So this is the x projection of OB and this is the y projection of OB. After that we need to we have expressed OB. Now we need to know the magnitude of OB. So basically what we need to do is OBX whole square plus OBY whole square, that x coefficient of x unit vector for OB, or we can say the x projection of OB whole square plus y projection of OB's whole square. So we get the amount 7.43. So now to know what is the direction of OB, we need to know the angle theta it is making with x-axis. So in this x-axis, so OB has a y projection and also a x projection. So we know that the best way to find the angle is the tan theta. So tan theta is here, is this, which is OBY. This is the y projection OB has, and this is OBX. So tan theta is OBY by OBX. We know what is OBY, that is 3 plus 5 by root 2, and OB is 5 by root 2, which give us 61 degree 35 minute. Okay, so basically tan theta of any you can measure by perpendicular by the base. So y direction projection of OB, here it is for y direction projection is OB and by x direction projection of OB. So the vector is making 61 degree 35 degree north of east, and it is 7.43 mile. So when we want to comment on the resulting vector, we need the magnitude as well the direction, both. Always remember that. The second example is similar, that find the sum of the resultant of the following displacement, that is not 10 feet northwest, then 20 feet north, 30 degree north of east, then 35 degree due south. So first A, 10 feet northwest. So that is 10 feet northwest. So for northwest, we know the x projection is the negative direction, so we put the negative, and the x projection will be the OA or 10 into what is the angle they are making with the x-axis, that is 45 degree. So minus 10 cos 45 degree x plus 10 sin 45 degree y, that is 10 feet northwest. Then B, next like movement is 20 feet 30 degree north of east, that is 20 feet 30 degree north of east, that it is making 30 degree with east. East is x-axis, so we can write AB as 20 into cos 30 degree x plus 20 into sin 30 degree y. Here it is in northeast direction, so x and y both the projection are positive. C is 35 degrees south, 35 feet south, so it is in this direction, that is here that should be BC. So it is in a minus direction, so minus 35y. So we need to add those things now. OA, then AB, then BC. Then we add the coefficient of x unit vector. Always remember, x can be written as I, and y can be written, x unit vector can be written as I. Y unit vector can be written as j, and z unit vector can be written as k. So we now add the coefficient of x unit vector, y unit vector, and add them. So finally we get this solution. Now we know we made the calculation and put the value, that is 10.249i, which is actually x minus 17.92y. So the resulting vector has a direction which is in a positive x direction but negative y direction. So we can see it is in southeast direction, but still we need to find the angle. So basically we see we need to find the magnitude. So the x projection, which is 10.24 whole square, plus y projection whole square, that give us 20.64. Now when we are trying to find theta, I suggest don't put the minus sign with the y projection. Just seeing this, firstly decide in which part of quadrant it is. If you put minus sign and you can handle that well, you will get at the same result. So this value is root 3, and tan inverse root 3 is 60 degree. So here we have already decided by this that x projection is in positive direction and y projection is negative direction, that is in southeast. You can see that is 30 degree south of east, or 60 degree, resultant is 60 degrees south of east and 20.64 mile in magnitude. And another similar like question is, an airplane moves in northwesterly direction at 125 mile per hour relative to the ground due to the fact there is a westerly wind which is for 50 mile per hour relative to the ground. How fast and in what direction would the plane have traveled if there is no wind? So basically we denote W by wind velocity, which is westerly wind. Westerly wind is the wind is coming from west to east. So west to east, this is positive x direction. So plus 50x. Velocity of plane without wind is VB and velocity of plane with wind is VA. So basically wind is blowing this way and velocity of plane is in this VB way. We also know if the resultant vector of two vector can be drawn diagonally of a rectangle whose each side is the two vector of whose resultant we are trying to obtain. So basically here one side is W and another side is VB of a rectangle. We make the rectangle and resultant is along their diagonal. So VA is equal to VB plus W. Okay, so VB is VA minus W. So we know W is plus 50x and VA is in a northwest direction. So here it has a minus x projection, or the projection is minus x axis and positive y axis, and the angle it is making, it has been said that it is in northwest direction, so it is making 45 degrees. So minus 145 cos 45 degree x plus 125 sin 45 degree y, we get this thing, and then normal vector addition negative is also up addition in with a negative value, so we get this. So here we can see that the x-axis, the coefficient of x unit vector is negative and coefficient of y unit vector is positive, so it is in this quadrant, which is northwest. Now we need to calculate the magnitude. We have that it is 163, and we need to calculate the basically angle. So tan inverse y direction projection by x direction projection would give us 30 degrees. So 30 degree north of west, that is our angle. Now when to question number 4. 100 lb pound weight is suspended from the center of a rope as shown in the figure. Determine the tension in the rope. So that is the rope. The tension is in this direction, and 100 lb is suspending from the rope. So the tension is in direction, okay? It is making 60 degree. So this is T cos 60 degree because the angle is making 60 degree. If we want to have this thing in cos direction, so it will be T cos 30 degree. But cos 30 is equal to sin 60, we know. So basically we don't need this kind of hassle. But be careful, T is making 60 degree angle with this thing. So this projection will be T cos 60 and this is T sin 60. So 2T cos 60, 1T cos 60 for this tension and 1T cos 60 for this tension is balancing 100 lb, and this T sin 60 is balances this T sin 60. So 100 is equal to 2T cos 60 degree is cos 60 degree is half, so T is equal to 100. So what is determine the tension is T. We were being asked to determine the tension T in the row, so we have determined the T, which is 100 lb. And another kind of question I discussed that day, that determine if vectors are linearly independent or dependent. So vector or set of vector is called linearly independent when none of them is a linear combination of others. How can you know that? So by written the vectors in a determinant form and but finding the determinant. So here we are given two questions, that is A is equal to this, B is equal to this. A is 2i plus j minus 3k. I have mentioned already I is equal to x unit vector, j is equal to y unit vector, k is equal to z unit vector. I, j, k all are unit vectors only. So write the vectors to know if the vectors are linearly dependent or independent, if one of them is a linear combination of two others. So write them in a determinant form like this: ax, ay, az. X is the coefficient of x unit vector, ay is the coefficient of y unit vector, and z is the coefficient of z unit vector of a. If it is 0, if the determinant ax, ay, az, bx, by, bz, cx, cy, cz is equal to 0, that means they are dependent. One of them is a linear combination of other two, but it's not equal to 0, that is independent. So here when we put this, we can see that the determinant is 0. That means that one of is linearly independent vectors. The set is linearly dependent vectors, and one of these are a linear combination of other. But there is another question. For that, A is equal to I minus 3j plus 2k, B is equal to 2i minus 4j minus k, C is equal to 3i plus 2j minus k. The determinant is non-zero, so they are linearly independent vector. Now there is another kind of question for vectors, that obtain the value of this identity. So we know A cross B cross C is A dot C minus A dot C B minus A dot B C. So A dot C is a scalar, A dot B is a scalar also. Here A cross B cross C lie in the plane of B and C. B cross C cross A lie in the plane of C and A, and A cross B cross lie in the plane of AB. So here we can see here the coefficient of C is A dot B, and here is the coefficient of C is B dot A. So we know for scalar product A dot B is equal to B dot A. Similarly, B dot C is equal to C dot B, and A dot C is equal to C dot A. So the resultant would be 0 because they cancel out each other. Again, another kind of question is, if A plus B dot A cross C cross product A plus B, what will be the answer? Here we assume that A plus B is P. You can assume it's capital A, and A cross C is Q. You can also assume it capital B. So this identity become P dot Q cross P. but we know for scalar dot product A dot B cross C is B dot C cross A. So A here P, B cross C can be written as B dot C cross A, and we also, so it becomes Q dot P cross P, and we know that this will be 0 because any vector when cross multiplied by itself, it gives us 0 because cross multiplication is P sine theta. Theta is 0 degree, that's why it is 0. So this identity is 0. Okay. There, excuse me. Here, I want to discuss a few inequalities that it is better to remember. What are these equalities? That the magnitude of A plus B is always will be less or equal to magnitude of A plus magnitude of B. The magnitude of A minus B is always be greater than equal to magnitude of A minus magnitude of B. The magnitude of A plus B plus C will always be less than equal to magnitude of A plus magnitude of B plus magnitude of C. And always remember these things. That we cannot add vector with a scalar. If we add, it will not give 0. Okay, that how can we add a direction, there is a vector in a direction with a scalar 6. So here there is example that A dot B plus 6C is equal to 0. Is it mathematically legal or illegal, or valid or invalid? So A dot B, the dot product of two vector, will give us a scalar, and 6C is a vector. So if A dot B plus 6C is gonna 0, that means 6C is equal to minus A dot B. So that means a vector is equal to scalar. That cannot be possible. So a vector plus a scalar cannot be 0. Then there is question 7 or example 7, as we can speak, that find the work done in a moving find the work done in moving an object along with a vector r, which is 3i plus 2j minus 5k, if the applied force is 2i minus j minus k. So we know that work done is F dot r. So here this is F, this is r. So we need to multiply the I component or x component, that is 2 into 3, plus here it is minus 1 into 2. Here the y component or j coefficient is minus 1, and here it is 2, and here the k component coefficient is minus 1, here minus 5. It gives us 9. So work done is 9. Now the same question can give you in a different way. Find the work done in moving a particle from 2, 1, 3 a space to 5 comma 3 comma minus 2 under the force F, if you already know F, so you need to, for work done, we know what is basically force dot displacement. So the displacement here is the r. So we need to know what is the displacement in a scalar form. So how can we know that? We can minus the initial point from the final point. So final point is 5, 3 minus 2. We can write it's 5. 5 is in the x direction. So 5x plus 3y minus 2z, because 3 is in the y direction and minus 2 in the z direction. Minus, this can be written as 2x plus 1y plus 3z, because 2 is the x positive x direction, 1 is the negative positive y direction, and 3 is the positive z direction. So 3x plus 2y minus 5j, because 5x minus 2x is 3x, 3y minus 1y is 2y, minus 2z minus this is 5z. We can write it as a 3i plus 2z minus 5x also. So we got the r and got the f, and we know the r is same as the r we were given, but here r was not given. R was stated like this: work done in moving a particle from this coordinate to that coordinate, that can be anything. So here also the work done is, we can calculate the work done. As we have the same f and r, the work done here is also minus. So we can like discuss some problems, that is, prove that the diagonals of a parallelogram bisect each other. So let us draw a parallelogram. Okay, so this is A, B, C, D. Okay, so now the diagonals are bisecting each other at point P. So AB is equal to A, BC is equal to B, DC is equal to A, and AD is equal to B. Okay, so here in this parallelogram, AP, there is a vector, BP is also a vector, PC is a vector, PD is a vector. Okay. So from this diagram we can see that BD plus A BD plus A is equal to B. Okay. Then BD is equal to, can we say, B minus A. So can we say X is equal to B minus A. X is a scalar, here X is 1. And we can also see that AC is equal to A plus B. Okay, sorry. BD is equal to B minus A. So BP, the whole thing, BD, P lies on the P lies on the BD, so BP will be X into B minus A. And when AC is A plus B, P also lies on the AC, so AP is Y A plus B. So we know AB, which is this, AB, we can say AB is equal to AP, then PB. PB. So which is basically AP minus BP. AP we know is Y A plus P. We don't know it is P is the middle point of BD or AC. Minus BP is X into B minus A, which give us X plus Y A plus Y minus X B. So we know that A and B are non-collinear by the picture, because if x1a plus x2 sorry x1a plus x2 equal to here x1a plus y1 b is equal to x2a plus y2b, then we can write this as a x1 minus x2a plus y1 minus y2b, which is can be written as x1 x2a is equal to y1 minus y2b. So a is equal to minus y1 minus y2, yx1 minus x2b. So a, hence it proves a and b are collinear. It happen when a and b are collinear. But here we can see that A and B are non-collinear. Then, this is kind of extra. then x plus y is equal to 1. What is AB? AB is equal to A. So coefficient of A will match with coefficient of A and coefficient of B will match with coefficient of B. So B coefficient is 0. So basically y minus x will be 0. From here we can see x is equal to y, and if x is equal to y, x is equal to y is equal to half. So basically we can see that BP is half of B minus A. AP is equal to half of A plus B. So basically P is the middle point of BD and AC. So basically the diagonals of the parallelogram bisect each other. So now the last problem is that find the magnitude of vector. Find the magnitude of 2r1 minus 3r2 minus 5r3, where r1 is equal to 3I minus 2j plus k. R2 is equal to 2I minus 4j minus 3k. R3 is equal to minus I plus 2j plus 2k. So basically 2r1, we need to calculate first 3r2 minus 5r3. So 2 into 3I minus 2j plus k. R2 is equal to 2I minus 4j minus 3k minus 5r3 is equal to minus I plus 2j plus 2k. When we will calculate all those things, it will be 6I minus 4j plus 2k minus 6I plus 12j minus 9k plus 5I minus 10j minus 10k. To all the calculation, it will be 5I minus 2j plus k. So then 2r1 minus 3r2 minus 5r3 will be, the magnitude of this will be, we can write this as a direct. So it will be 5 square plus 2 square plus 1 square, that is minus 2 whole square actually. That is actually root 30. That is the magnitude of a vector. So there is another question. There's find a unit vector to the resultant of vectors to I plus 4j minus 5k and 2 is equal to I plus 2j plus 3k. So resultant vector, let's say capital R is equal to R1 plus R2 will be 2I plus 4j minus 5k plus I plus 2j plus 3k. So the resultant R is equal to I plus 6j minus 2k. So for unit vector R, you need R by mod of R. So mod of j minus 2k, mod of R is 3 square plus 6 square plus minus 2 whole square, which is 3I plus 6j minus 2k, 9 plus 36 plus 4, which is 3I plus 6j minus 2k by 7. So we can write it like this. So I guess that's all for today, and we can discuss if you have any problem in the next class. Thank you.